Graphs of quadratic equations. Quadratic. Or even we'll call it functions. Equations, functions. Graphs of quadratic functions. And I'm going to say with vertical and horizontal shifts. So if I have, first we're going to do the basic example of a quadratic function. That we're going to graph y equals x squared. Or, so that'd be equation notation, or f of x equals x squared. So to see what this looks like, let's plot some points, and we'll pick out some definitions then. I'm going to leave some space, and I'm going to put 0 in the middle. And if I plug in 0 for x squared, 0 squared is 0. Or if x is 1, 1 squared is 1. 2 squared is 4. 3 squared is 9. And then I'm going to include some negatives. Negative 2, 1, negative 2, negative 3. So for these ones, if I do negative 1 squared, this will become a positive 1. Negative 2 squared, that's negative 2 times negative 2 is a positive 4. And a positive 9 when x is negative 3. So if I plot those points, 0, 0, 1, 1, 2, 4, so I jump up a bit, 3, 9, I jump up even more. And then x is negative 1, y is positive 1, negative 2, positive 4, and then a coordinate of negative 3, positive 9. So this is a parabola. Looks like a U shape. So a couple of definitions to pick out of this is that right here where that low point is called the vertex. So the vertex in this example is 0, 0. The other thing to pick out is that if I had a line that I folded this parabola in half, and it would be the same thing. I'm going to draw this dotted here, dotted down this. So this dotted line that I just drew, this is called the axis of symmetry. Axis of symmetry. Symmetry. I think that has two M's. Symmetry. So the axis of symmetry, it's a vertical line, and vertical lines always have an equation x equals something, and in this case the value of x is 0. So this axis of symmetry is x equals 0. Or it's actually the y-axis. Okay, so that's the most basic quadratic function to graph. Now let's look at if I put a number in here. So if I have, we're going to graph f of x equals x squared plus 3. So let's look what happens with this example. So if I again pick 0, 1, 2, let's put the positives below. 0, 1, 2, and then negative 1 and negative 2. That should give us the pattern. So if I plug in 0 for x, 0 squared plus 3 is going to be 0 plus 3 is 3. And then if I do 1, 1 squared plus 3, 1 plus 3 is 4. 2 squared is 4, plus 3 is 7. Negative 1 squared, negative 1 squared is 1, plus 3 is 4. Negative 2 looks like it's going to have the same answer as positive 2, because that'll be 4, plus 3 is 7. So let's see what this looks like compared to the first one. So 0, 3, I'm going to plot that one first. 0, 3, and then 1, 4, and 2, 7. Okay. And then negative 1, 4. and negative 2, 7. So it still looks like it's taking this form of a parabola. The only difference is that, notice, it's the whole parabola shifted up 3. So we'll talk about that more in a minute, but just take note that this is like x squared moved up 3. Let's pick out those two definitions we talked about in the first one. The vertex is this point. It's a point always, so we're going to give it coordinates of 0, 3. So right here, that was our low point of the parabola, the kind of the starting point if we think of it that way, but it's the minimum. And then the axis of symmetry is, it's always a vertical line. In this case, it's still x equals 0. Okay, because this is this line right here. X equals 0. Okay, so let's do another example. So this, the other thing I want to point out is that this is a vertical shift because it moved up. We'll talk about in a minute why it would move down, but if you can guess, it has to do with this sign right here. The plus 3 means it moved up 3. If it was a minus here, it's going to move down. And I'll give you a definition for that in a minute. But and then, let's see. There we go. Let's see what happens in this one. So this is kind of another difference. F of x equals, in parentheses, x plus 3 squared. So still plus 3, but now it's inside the parentheses. So let's look at the difference with this. If I plot some points. So 0, 1, 2, negative 1, negative 2. So if I plug in 0, I'm going to have 0 plus 3 is 3, squared is 9. 1 plus 3 is going to be 4, squared is 16. These seem to be a lot bigger numbers. 2 plus 3 is 5, squared is 25. Okay, let's see what happens when I do the negative. Negative 1 plus 3 squared. So that's 2 squared is 4. And then negative 2 plus 3 squared is 1 squared. Which is 1. So I think, let's see what this looks like so far, but I might need to do some more points. So negative 2, 1, negative 1, 4, 0, 9, and then these other ones are off the graph because basically right here it's this part of the parabola going up. So let's see what's happening over at x is negative 3. So if I do negative 3 plus 3 squared, don't want to do that. Negative 3 plus 3 squared is 0. Squared is 0. So negative 3 is 0. And then how about negative 4? Negative 4 plus 3 is negative 1. Squared is going to go back to positive 1. So it looks like I go back up. So this looks like, I'm just going to we could do a few more points, but I'm just going to sketch in approximately. This is what our parabola should look like. So in this case, the vertex is negative 3, 0. Negative 3, 0. And the axis of symmetry is x equals, now this one's going to be a little different because this vertical line, that if I folded the parabola in half, it would be symmetrical, it would match up. This is at negative 3. X is negative 3 is the axis of symmetry. So notice this one. This one we shifted left. It's like the regular x squared shifted left 3. Which is kind of, if we looked at the initial equation, usually our first gut reaction would be like, okay, if it's on the inside, that might mean it's a horizontal shift, you know, that we just kind of looked at this example to see that. So we think, okay, plus 3 is to the right 3. But actually the horizontal shifts, when the number's on the inside, it's the opposite of what you think. The plus actually means I'm going to move to the left. Okay, so we kind of just proved this by coming up with those points. So I'm going to give some definitions for these shifts that we just kind of figured out by graphing. So I'm going to put shifts for quadratic equations. Or functions. I'm going to actually use function notation here. So shifts for quadratic equations or functions. So the first one is that f of x equals x squared plus k is f of x equals x squared shifted up k. Up k. So this is like our x squared plus 3 example we did. It moved the whole graph up. The next one is that if I have f of x equals x squared minus k, this is f of x equals x squared shifted down k. So if it's subtraction on the outside, I'm going to shift the whole graph down. Now the inside ones. So if I have x plus, I'm going to use h here, x plus h squared. So now the value, the h, would be on the inside. So this is f of x equals x squared shifted. So remember, you would think plus is to the right, but it's actually left h. And then last, f of x equals x minus h squared is f of x equals x squared shifted right h. So if it's a minus on this inside, I'm going to shift the whole graph to the right. So let's do one more quick example using what we just figured out. If I want to graph f of x, parenthesis, x minus 3 squared minus 4. So we're going to use this information on. We're not going to plot points. So based off of this, minus 3, so minus 3 on the inside, this means I'm going to go to the right 3. And the minus 4 here means I'm going to go down 4. So I'm talking about moving my general x squared graph. So basically that 0, 0 vertex that I usually have, instead now I'm going to go to the right 3, down 1, 2, 3, 4. Now my vertex is right here. So my vertex on this one is going to be 3, negative 4. And if I sketch that in, and I'm not getting my x-intercepts quite accurate or even making this look very much like a nice parabola, but something like this where my vertex is 3, negative 4 and my axis of symmetry, I'm going to abbreviate there, would be x equals a positive 3 because this is me the vertical line going through at a positive 3.